So this video will be just a quick one to review on compression molding. This stuff where it is not in the slides, but I think just do it over here in case in the future that you may need it or whatever it is. At least it's easier. But however, before going, if you still remember, we have actually lacked a page called the dry or preg laminating. Alright, which in other words is a prepreg. Alright, I'll not go into details on that, you can just remember them. Alright. And if you take a look from page 102, slide 1, alright, I mean lecture note part 1, alright, you can see that there's also the things that we have gone through, alright. So therefore on this part 2, alright, we also have another prepreg. Okay, so you need to take note of all the disadvantages and advantages and know how to articulate with that, alright. And therefore, if you were to come to this thing, alright, the prepreg is actually not a continuous lamination, it's something else. So therefore, let's see what is compression molding. You can just take a look on this compression molding, and yeah, let's take a look then.
In optimizing the shape. MFG has compression molding presses available from 100 tons through 3,000 tons for use with sheet molding compound, liquid composite molding, and carbon fiber. Beginning with the watershed event of molding GM Corvette components in 1953, MFG Composites has worked to continually improve the matched metal die compression molding process. This process is used in the production of bathware such as sinks, shower stall bases, and bathtubs, components for wind energy, and yes, even the latest, greatest Chevrolet Corvettes. Compression molding allows our customers to utilize in-mold coating to improve surface paintability. MFG Composites has the capability of developing color compounds for your parts. We partner with color formulators to provide colored composite materials to meet customer needs. Surface paintability.
So if you take a look, at a certain point, you can see that there is a certain material that is fitting inside the material, the machine. Alright, you give me a while. Yeah. So actually, you put a bakwa inside. You see. So it's like any material. I think you might have to heat it up, or perhaps no need to heat it up. But as you can see,
color compounds for your parts.
So once you compress it already, or eventually it become this shape lah. Okay. So generally, you have a certain fixed shape over here, and then once you compress it, or you'll become this shape. The rest of the little stuff will actually drop into this thing, alright, things like that. So or perhaps actually not lah. This is a ejector pin, so you eject the material out. Okay, sorry. So it's a fixed volume. So they actually pre-print everything already. So it's a fixed volume type of thing. So the molding material generally is already preheated, and then after that, then you put inside the cavity to compress. So you have to preheat the material before you compress. Alright, and it's a high volume, high pressure method, alright, for molding complex high strength material. Okay, so compression molding is actually quite a good significant technique. Alright, and it's for high volume composite parts. So if you want to do a lot of parts, as you can see the helmet, alright, you can high volume create it for, and it's relatively like so-called very stiff and excellent in whatever it is. So therefore, yeah. So we have no compression molding. So now let's talk about RRIM, reinforced reaction injection molding. So here's a very sad video on that injection molding. I don't know, I feel very sad when watching this video.
Offers reaction injection molding. For foam molding of cushions, pads, seals, or virtually any three-dimensional foam parts, there is no process better than RIM. RIM is a low-cost process, and the products generated have a tough skin and are durable, long-lived, and very functional. Materials used in RIM range from very soft polymers to semi-rigid polyurethanes. Inserts made of plastic, metals, or other materials can be overmolded for the purpose of adding rigidity, aesthetic appeal, or to provide mounting brackets to the product. RIM technology is ideally suited to low and medium quantity runs. RIM tooling is a fraction of the cost of conventional injection mold tooling. The risk is low, and the results are very rewarding. When you need foam molding, think Dymax.
So I think this is just somewhat it is, but the name is injection molding. So therefore over here you'll inject some resins, alright, and then you'll mix it up all together over here, alright. Then it will, once you mix already, and then you fit inside the mold, and then you create a shape, and that's all it is for the reaction injection molding. Okay, and relatively this is it's mainly used for polyurethane polymers, alright, where you use for spoilers, bumper covers, things like that, alright. And polyurethane are somewhat this type of material lah. Okay, you can agar just accidentally feel that this type of materials. Okay, for reinforced reaction injection molding is done. So therefore let's talk about vacuum infusion processing, and it's very similar to vacuum bagging. As you can see, it's filling up the material just like your vacuum bagging. So you have this type of material coming up. Oh, it's for solar panel. So now they are actually layering. Okay, so I actually go back to the before the vacuum thing. So they layer each layer by layer. And then you do things like the vacuum bagging that I've done already, you see. So this is where our resin is being fed into the thing and create a composite that we have. And if you search, you can actually see benefits of these are the benefits. There's actually an explanation for typical head layup usually results in fabric weight by resin. Alright, and the resin is very brittle for typical hand layout. So any excess will actually weaken the part. So therefore vacuum bagging itself reduces the number of the, actually I don't need to go through all this, but you can read it up yourself if you need. Alright, and there is certain pros and cons that they compare between the different methods. Alright, and this is the vacuum infused thing. And so here is they got different steps. Alright, you can read it up yourself if you're free. So therefore it's a very good website. Alright, so I would suggest you just go and search for vacuum infusion processing. Alright, and then the first one, alright, the first one, composites PDF, you can just click it up and check it out. So over here this is a video on centrifugal casting where it will start to turn. Manufacture. These are the things that you may want to understand. Alright, so they actually give me a while. They actually have this ladle where they pour in the molten, alright, and then molten will actually go into here, and then it will fit inside this thing, and this thing will keep turning and turning. The top rollers is to turn the thing, the bottom rollers is also to turn this thing. So there will be a catch over here to actually turn this thing. You see? If you don't know what the hell am I talking about, this thing and that thing, alright, it's this thing. Okay, so there will be a catch over here. So this catch over here is fixed onto this catch, so that when this thing push, it will push it down. Alright, and this roller I will believe is to roll this surface of it. Alright, no need to know much, but at least you gotta know that it's doing by centrifugal manufacturing. Alright, so it's used for manufacturing stock materials in standard size, so it's for large scale, so to speak. Alright, and this is another method because actually this method is for metals, but it also can be used for composite. So centrifugal casting is done, and therefore the last one is continuous lamination. This is the one for continuous lamination. So
two spigot ends are piped together. Use a grinder to roughen up the surface of the fiberglass. You want the laminate to get the strongest bond possible to the pipe surface, so wipe away any dust that can prevent this. Using a resin-based putty, fill the space between the two pipes to create a level surface for the fiberglass. Next, use a small container to mix the resin with a catalyst. This will begin the curing process. Your Flow-Tite representative will advise you on the proper amount of catalyst to use. The resin is applied to the pipe surface with a roller. It's important to apply the resin first and then roll the glass into the resin to avoid getting air bubbles into the joint. Then apply the first layer of fiberglass. Laminates are designed for specific purposes, so different layering sequences can be used based on different strength requirements. Again, your Flow-Tite representative will tell you the right number of layers to apply. Between each layer, use a serrated roller to work the resin through the glass and remove any air bubbles. Rolling also compresses the glass and forces out any excess resin. Work the roller from the center toward the edges. Repeat the process of applying resin and laminate until you have the recommended number of layers. Drying time varies according to climate.
So therefore, this is the continuous lamination process, and it's actually an automated one, but I don't know how it's being used. Alright, you can actually search for sorry, I shouldn't. Over here, this is a continuous laminated also, but I don't know what is going on. But there is a so-called machinery type of thing. So I think they are layering the composite. This is actually a metal, so I think they are actually laying the metal and moving it up. So they're actually layering the material again and again, you see. So this is a way to actually layer the material. I think it's trying to roll up the material also in a way that such that you don't break the material, I think. So I don't know lah, let you think about it lah. As for the pros and cons of all of them, you can just check it out yourself. But later on in the next video, I'll talk about the few key things. That is the pros and cons, and how to choose your processes, alright, based on volume. Normally we want to manufacture, so we have to know which type of volume is suitable for which type of processes, so that we can cut costs and things like that. Okay, so therefore in the next video we'll talk about open molding and closed molding that is related to our slugs, alright, which are all pultrusion, RTM and vacuum back molding. That's all. These are the three things for closed molding and the three things for the open molding. And yeah, so yeah.